Lesson 4 is our second of 3 introductory and mostly review algebra lessons. And at this point, if, like Lesson 3, if a lot of that, the majority of that was unfamiliar to you, and then as you start doing this lesson, if the majority of this is unfamiliar to you, that is a really good sign that you actually need to be in Algebra 2 instead of Precalculus, because a lot of what we're doing here is review from Shormann Algebra 2, and even that is review from Shormann Algebra 1. So these are fundamental algebra ideas in these introductory lessons that you should already have a fairly good grasp of. We're just brushing up on that, making sure that you get it. So here in Lesson 4 we have 3 parts. The first part is on linear equations. The focus here is on the algebra of linear equations, solving for one or more unknown parts of the standard or general forms. Look at your rules if you're not sure what the general form is. It's basically the y equals mx plus b format, except you just set everything equal to 0. So graphing linear equations, we're going to review that in Lesson 10. So here, example 4.1, let's go ahead and start some problems. Remember, you're supposed to do these. That's what you're doing when you're watching lectures and taking notes. The main thing is that you're doing example problems, hands-on, active, learning math. The best way to learn it is an active approach to it. Erasing, writing, solving problems, working things on paper, pausing and rewinding the lecture when you don't understand something. So being actively involved here. So 4.1, find the equation of a line passing through the point 1, 5, having a slope of -2. If you want to graph this to visualize it better, you can, but that's not our focus. Our focus is on the symbolicness of this, I guess, for lack of a better way to describe that, the symbolic form. So anytime you're asked to find the equation of a line, though, I've been talking about this since Shormann Algebra 1, write the standard form first. Y equals mx plus b. Find m, the slope, find b, the y-intercept, and you're done. So in a point slope problem like this, you've been given the slope, has a slope of -2. Substitute that in, y equals -2x plus b. Now how do you find b? Well, you've been given a point x comma y equals 1 5, so substitute that in now. Make sure you put the y value of 5 first. Just because it says 1 5, don't write 1 equals -2 times 5. No, the y value is 5. The x value is 1. So put that in the right place. 5 equals -2 plus b. Add 2 to both sides. B is equal to 7. So our form then is y is equal to -2x plus 7. That's our equation. Problem 2, find the equation passing through 2, 3 and parallel to y equals 3x plus 187.5. Parallel to, that's a little bit different than example 4.1, but one thing you should know, and this is one of those things to make a note of in addition to the problem, is remember parallel lines have the same slope. So make a note of that. That means our new equation, we can write down the standard form first, y equals mx plus b, find m, find b, and you're done. Y equals same slope if they're parallel, so our slope is 3 for our new line. Y equals 3x plus b. Now all we have to do is find b, and we can use the point that we've been given again. And keep in mind, this 187.5, we don't need that at all. We don't have to worry about that. So if you didn't know that already, then you're like freaking out about this big number. You don't need it. It's not important. 3 is equal to 3 times x is 2 plus b. 3 equals 6 plus b, so b is -3. Y equals 3x minus 3. That's the equation of this line that passes through 2, 3 and is parallel to y equals 3x plus 187.5. It has the same slope. Problem 3, find the equation of a line passing through 2, 3 and perpendicular to, so a little bit different again, perpendicular to y equals 3x plus 187.5. So perpendicular to the same line, and it's passing through the same point, but perpendicular to, that means its slope will be the negative reciprocal of this other line. So the new m is the negative. It's the reciprocal of 3, which is 1 over 3. And then it's the negative, the opposite of that, minus 1, 3. So our new line, y equals mx plus b, it has a slope of negative 1/3 x. That's another idea there to write down in addition to the problem and solving the problem. Perpendicular, we find the negative reciprocal of the given slope. Find the negative reciprocal of that given slope. Y equals negative 1/3 x plus b. Substitute 2 comma 3 in. 3 is equal to minus 1/3 times 2 plus b. So that's a minus 2/3. Add 2/3 to both sides. So that 3, we can make that into a 9/3 plus 2/3. That's 11/3 is equal to b. So our new equation then is y is equal to minus 1/3 x plus 11/3. Parallel lines have the same slope. Perpendicular lines, their slopes are negative reciprocals of each other. And notice this one. There's one more thing we have to do here. It said write the equation in general form. So in general form, that is ax plus by plus c is equal to 0. So we don't want any fractions. We want to try to get rid of all the fractions. So we would do that by multiplying every term by 3 first. So all of this by 3. And that would give us 3y is equal to minus x plus 11. Now just move everything over to the left side and have equals 0 on the right side. So that would end up giving us x plus 3y minus 11 is equal to 0. There's our general form. X plus 3y minus 11 equals 0. Just another way to write an equation of a line that you need to be familiar with. One more for part A here. Find the equation of a line passing through those 2 points. Write the equation in general form. And maybe you remember Euclid's first postulate. That explains that all you need is 2 points to define a line. So this one, we haven't been given a slope or a slope that we can find the negative reciprocal of. So we just take the change in y over change in x. That's how we'll find the slope first. But let's write our standard form down first. Y equals mx plus b. And m is equal to y2 minus y1 over x2 minus x1. And it doesn't matter which ordered pair you do first. Just keep them in the same order. So I'll say my first values, my 1s are 3 comma 3 and my 2s are the 6 and negative 2. So I'll say y2 is negative 2 minus y1, so minus 3, over x2, which is 6, minus x1, which is 3. So minus 2 minus 3 is minus 5, over 6 minus 3 is 3, minus 5/3. That's the slope. Y equals minus 5/3 x plus b. I have 2 points I can choose from here to solve for b. It doesn't matter which one. Either one's going to give me the same y-intercept because it's the same line that I'm working with. So I'm going to use 3 comma 3 because then there's no way I can mess up and put it in the wrong spot because x and y are the same value. So I'll say 3 is equal to minus 5/3 times 3 plus b. Those 3's will cancel there. I have 3 minus 5 plus b. Add a 5 to both sides. b is 8. So now I have y is equal to minus 5/3 x plus 8. I want this answer in general form. So not like it is right now, in other words. So I want to get rid of the fraction, so I'll multiply everything by 3. That gives me 3y is equal to minus 5x plus 24. So move everything to the left. 5x plus 3y minus 24 equals 0. That's the general form. We don't use this general form a lot, but it's just good to test some basic algebra skills to be able to use it. The main form is the standard y equals mx plus b slope-intercept format, and one reason that's so important is because slope is so important in algebra and in calculus also. When we put something in general form, just the slope kind of disappears in there. Moving on to part B on systems of linear equations, and here we'll review systems of 2 and 3 equations using combinations of substitution and or elimination to solve them. So look at example 5. Solve the following system. Write the answer as an ordered pair. These are normally designed to simplify into fractions, integers. One thing we want to do is try to be as efficient as possible when we solve these, and it doesn't matter if you use substitution or elimination. I'm going to solve this one particular way. It's not the only way. The key, the most important thing on these is that you get the right answer and that you solve it in an efficient way. You don't want to take the most number of steps possible to solve it. You want to do it as efficiently as possible. So what I'm going to do is look at that first equation, x plus 7y equals 3, and I already have just an x by itself there, so just rearrange that. X equals 3 minus 7y, and that's easy enough right there to substitute in for x in the bottom equation. And then we just have one equation in terms of y. So let's do that. We'd have 2 parentheses 3 minus 7y plus 3y is equal to 1. Expand out. 6 minus 7 times 2 is 14y plus 3y is equal to 1. 6 minus 11y is equal to 1. And move that 6 over. Minus 11y is equal to minus 6 plus 1 is minus 5. Y is equal to 5 over 11. So if y is 5 over 11, then x is equal to 3 minus 7 times 5 over 11. Now we can solve for x here. That would be 3, or let's just write that as a fraction over 11. That would be 33 over 11. Minus 7 times 5 is 35 over 11 is minus 2 over 11. That's what x is. Be careful, just because we solved that second, that doesn't mean it's y. That's x. Our solution then is minus 2 over 11, comma, 5 over 11. We want to write that like the question said. It said to write it as an ordered pair, x, comma, y. Minus 2 elevenths, comma, 5 elevenths. That's our solution. Not so sure you did it right? You can check it by substituting those numbers back into either equation. And so we could substitute it into the bottom equation. 2 times minus 2 over 11. That would be a minus 4 over 11, right? And then 3 times 5 over 11 is a plus 15 over 11. Minus 4 plus 15 is 11 over 11, which equals 1. Well, that's what the equation is, right? 2x plus 3y equals 1. So we've confirmed that we solved that problem correctly. So you can always check your work by substituting back into either of the original equations. Problem 6, solve that system. And notice this time that your y terms are equal and opposite. So just add those two equations together, and that will eliminate the y values. That's called elimination. So problem 5, we use substitution to start with. Here we can just eliminate. Adding 2x and 5x is 7x. 3y minus 3y is 0. 4 and 6 is 10. X equals 10 over 7. Substitute that now into either equation. I'll substitute into the top one. 2 parentheses 10 over 7 plus 3y equals 4. 20 over 7 plus 3y equals 4. Move that 20 over 7 over, we'd have 3y is equal to 4, multiply it by 7 over 7 and make it a 28 over 7 minus the 20 over 7. That equals 8 over 7. Divide both sides by 3. Y is equal to 8 over 7 times 3, 8 over 21. So x comma y is equal to 10 over 7 comma 8 over 21. Not sure about that? Check it. Substitute those into either equation. I'll substitute into the top equation. 2 times 10 over 7 would be 20 over 7. Plus 3 times 8 over 21, that would give me 24 over 21, or actually the 3 over 21 would simplify down to 8 over 7. So that'd be 28 over 7. And that does equal 4. So we check that, and then that confirms to us that 10 over 7 comma 8 over 21 is the correct solution. And problem 7, now we have 3 unknowns, an ordered triple. So if this was analytical geometry, which we'll be covering starting in lesson 9, we'd be thinking about x, y, z axes. We'd be thinking in 3 dimensions here. This is like a 3-dimensional problem. So what we ought to do is get this in a form that's more familiar to us, like, for example, 2 equations, 2 unknowns, and just look, what do you think the most efficient way to do that would be? So just scan through the 3 different equations that you see there, look for similarities, look for things that maybe you could easily eliminate. Like, look at this, plus 2y minus 2y. If you added those 2 equations, you get rid of the y's really fast. And then if you took the top equation and multiplied it by this middle one times 2, then you'd have a negative 2y plus 2y again. You could eliminate, and you'd end up with 2 equations in terms of x and z. And so those 2 equations and 2 unknowns, you could simplify those. So you basically add one more step to the system of equations process to get that 3rd unknown taken care of. And so let's go ahead and do that. Let's just write these out carefully. X plus 2y minus 3z is equal to 13. And then the bottom equation underneath it, 4x minus 2y minus z is equal to 9. And add these 2 together to get rid of the y terms. 4x and 1x is 5x. Minus 3z minus 1z is minus 4z is equal to 13 plus 9 is 22. Then again, x plus 2y minus 3z is equal to 13, and multiplying that middle equation by 2, everything by 2, that would give us 6x minus 2y minus 2z is equal to 8 times 2. Don't forget that. 8 on the end there, that's 16. Add those together now. 6x and 1x is 7x. Y's cancel. Minus 3 minus 2 is minus 5. Z is equal to 13, and 16 is 29. So now I have 2 equations, 2 unknowns. What should we do with those? We could eliminate the x's or the z's. So it doesn't look like anything easy to do that with. So I'm just going to take that top equation, multiply everything by negative 5. Take the bottom equation, multiply everything by 4, and then I can get plus and minus 20z and get rid of the z's and solve for x. So let me move that over. 7x minus 5z is equal to 29 times positive 4. So let's just do this mentally. Keep up. Minus 5 times 5x is minus 25, and then a 4 times 7x is a 28. So I have a minus 25 plus 28x is a 3x. The z's are going to cancel. Then I have minus 22 times, or 22 times negative 5 is minus 110. 29 times 4 is a positive 116. Minus 110 plus 116 is a 6. 3x equals 6. So that means x equals 2. Over here at the top right, I wrote that down. I can take that and solve for z now. I'll just use 5 times 2 for x minus 4z is equal to 22. Minus 4z is equal to 22 minus 10 is 12. So z is equal to minus 3. So now I can take the x and the z, substitute it into any of the equations. I'll do the top equation since that's just an x. It has kind of the smaller numbers in it. So we'd say x is 2 plus 2y minus 3 times minus 3 is plus 9 is equal to 13. 2y plus 11 equals 13. So 2y equals 2, y equals 1, and we're left with 2, 1, negative 3. That's our xyz pair. You could substitute that into any of the equations to check it if you want to. Well, now let's move on to part C on rational equations. And some of these equations are similar to the equations you set up when solving ratio word problems. So you see some similarities there, and kind of had to do some algebra in those. With rational equations, think get rid of the fractions first. So one of those extra things to write down on top of the problems when you're doing rational equations, think get rid of the fractions first. You can either cross multiply or by multiplying every term by the LCM, least common multiple of the denominators. So look at example 4.8, solve for x. We just see fraction equal fraction. Easiest way to solve those is cross multiply. Notice we're not solving for a. There's two variables here. That's okay. Just cross multiply. X times a, say is ax, is equal to 2 times 7 is 14. Divide both sides by a. X equals 14 over a. That's our answer. We're not trying to find some specific number here. We're just looking at that equation, solving for x. 14 over a is the result. Example 4.9, solve that for x. And hopefully you can see there the least common multiple. This is one of those get rid of the fraction first problems. So looking at everything there, multiply everything by 10x. That'd be the least common multiple of the denominator. Terms, values, whatever you want to call them. So multiplying everything by 10x, we'd have 10x times b over 2. 10 over 2 would simplify to 5, and that would give us 5bx is equal to 10x times 1 is just 10x over 5. That'd be 2x. 10x times a, the x's would cancel, minus 10a. Remember what we're solving for here. We're solving for x. So now what we want to do, we've got the fractions eliminated, and that's always a good first step because it makes it easier to work with the problem. And isolate all of the terms that have an x in them and then factor that x out. So that's going to allow us to solve for x. So now we'll say 5bx minus 2x equals minus 10a. X, factoring that out, 5b minus 2 is equal to minus 10a. And then divide both sides by 5b minus 2. X equals minus 10a over 5b minus 2, which is the same thing as saying 10a over 2 minus 5b. So we got rid of that negative sign there by multiplying, mentally multiplying above and below by negative 1. If we multiply above and below by negative 1, we're just multiplying by 1, right? But that allows us to get rid of that negative sign and not lose it accidentally or something. So minus 1 times minus 10 is a positive 10a. Minus 1 times 5b minus 2 is 2 minus 5b. So that's a good step to do on a problem like this. And it's also good to recognize if you wrote minus 10a over 5b minus 2, and let's say this was a multiple choice problem, and one of the choices is 10a over 2 minus 5b, you need to recognize those are the same thing. Let's do one more. Solve for k. On this one, we ought to get rid of the parentheses first. So expand that, then find the LCM and get rid of the fractions. So we'll say y is equal to b over k minus ab over cx. And so we see that the least common multiple would be ckx. We can multiply everything by ckx, and that would give us ckyx is equal to, the k's would cancel in b over k, so we'd have bcx minus, the cx's would cancel here, so we'd have minus a b k. We're solving for k. We're not solving for x. We're not solving for y or for a or anything like that. We're solving for k. So that means we need to isolate the terms that have a k. Get those on the left, preferably. It doesn't have to be on the left, but that's what we'll do here. So we'll say a b k plus c k y x is equal to bcx. And then we'll factor the k out. K parentheses a b plus cyx is equal to bcx. So that means k, I'll just write it over here, k is equal to bcx over ab plus cx y, just writing that in alphabetical order there. Now, does it matter if I have cxy plus ab or ab plus cxy in the denominator? No, it doesn't matter. Just like it doesn't matter if I had 2 plus 1 or 1 plus 2. That order doesn't matter. You need to recognize, though, if it was a multiple choice problem and the denominator had cxy plus ab and you had written ab plus cxy, that those are the same thing. Okay, well, that's all for lesson 4.